order of operations are important, and you may have come across acronyms like BODMAS or PEMDAS to remember which order to operate in. First, let's expand what each of these mean. So brackets or parentheses, that's what you always start off with. Then you've got exponents or orders of, and then you've got division, multiplication, addition, and subtraction. Now, I'd like to group this very quickly in terms of what sort of unit they operate in. This is one, this is one, this is another one, and the same here. So, first of all, let's start with brackets, because I think that's the simplest. We have our first reason, which is notation. So we have assigned a particular symbol to mean something. And if you take addition, for example, this symbol means addition, this symbol means multiplication, and so on. This is for division, this is for subtraction. In a similar way, we use brackets to say this must be done first. So this is just simply a matter of notation. If you want to do something first, then just put it inside brackets. Our second sort of group is convention. And what you notice is that in these two orders of operations, the acronyms, you'd see that division and multiplication is switched around. And the reason is because it doesn't really matter which order you do it in. And again, the reason for that is because of this grouping. So if you have a look at addition and subtraction, they operate on individual units. So you've got, let's take an example. I think that really explains it a bit better. Let's say you've got 2 plus 2. And we have that equal to something. Basically, this is operating on units. You've got 2 units of something, and you're adding it with another 2 units of something, and you're getting 4. Subtraction also works on singular units. This is as opposed to multiplication and division, which works in groups. For example, if you've got 4 times 3, which is what we have represented as, well, actually, I guess it doesn't really matter, but let's say you've got 3 times 4. You've got 3 groups of 4. So if we had to do our grouping here, we'd say this is one group of 4. This is another group of 4. And this is our final group of 4. So you've got 3 groups, and inside each group we've got 4 elements. So this is working on groups of units. So it's not working on units anymore. So this is why we've got this taking precedence over that. And well, the answer to this is 12. This is where convention comes in. So let's say you've got this example. Let's see, 2 times 3 plus 4. Now, one way you could interpret this, and we're going to use our notation for brackets here. One way to interpret this is by saying you can do 2 times 3 first and then plus 4. So we represent this like this. Or you can do the 3 plus 4 first and then multiply it by 2. And both of these yield different answers. So 2 times 3, that's 6, plus 4 is equal to 10. And if you do it this way, this is 3 plus 4 is 7, and 7 times 2 is 14. So these represent 2 different things. And by convention, what we say is you must do multiplication first. So if we haven't written any brackets, this could, technically mean either one of these. You could say that you must do the multiplication first, or you must do the addition first. It doesn't really say which one. So you can say that this is ambiguous, and you can say that you can't write stuff like this is invalid. But that's not very useful, so what we use is a convention. So if we haven't specified, these brackets, then just assume that you have to do multiplication first and then your addition. So this state is assumed, and that's just simply convention. You could do it the other way, but then you'd have to ensure that everyone else that you're working with also does it that way, which is quite difficult. So as a general rule, you'd follow, again, this sort of grouping. If something looks ambiguous, then you'd do exponents first, then multiplication or division, and then addition or subtraction. Okay, so we've come to addition and subtraction. We know that it can be operated interchangeably. So if you've got 2 plus 3 minus 4, it doesn't matter which order you do it in, you'll get to the same result. So you can do it in whichever order you like. Sometimes, by convention, you might prefer to do it from right to left, but it doesn't really matter. You'll always get to the same answer. But that's not the case for multiplication and addition, as we saw. And for that, we have convention, so that you prefer one over the other. Now, for the last part, we have got exponents, and you'd have to do that first, again, by convention over multiplication and division and addition and subtraction, because it represents a different unit again. So with addition and subtraction, we said that we're operating on individual units. For multiplication and division, we're operating on groups of units. And for exponents, in this example, we've got 4 to the power of 3. So this is 4 to the power of 3, which is the same as 4 times 4 times 4. And this is operating at a different grouping level than the multiplication. So for multiplication, we had groups of units. This is working with, I guess, groups of units. So you've got one group of 4. So this is obviously one sort of grouping, and you've got 4 of those. So this is another group, and because it's 4 to the power of 3, you're saying you've got 3 of these groupings. So once more, you've increased the grouping level. So this is sort of like nesting different elements into each other. And the reason you can't do, for example, 4 to the power of 3 times 3, the reason you can't say, well, this is equal to 12 to the power of 3 is because of this grouping. Multiplying by 3 operates on this one level of grouping, so grouping of individual units, whereas 4 to the power of 3, that's operating on grouping of groups of groups, so multiple nested groups. And this also doesn't make sense logically, because what we mean by this, the notation for this, is multiplying 4 by itself 3 times. So 4 times 4 times 4. This is obviously very different from what this represents, which is 4 to the power of 3 times 3 to the power of 3. This is very different from multiplying the 3 out 3 times. So this doesn't make sense logically, and if this is kind of confusing, you can't think about this all the time, you probably learn it as a law, or you should just follow this abbreviation. And the reasoning should be clear. I mean, this should make sense. If you do it enough times, I guess it makes sense without even questioning it. But even if you do question it, it should make sense. This is the notation that we've defined. This is the convention we follow, because there is some ambiguity in our notation, and some things don't logically work.